Hello everyone and welcome to the Rust security class. By the end of this class, you'll have all the knowledge required for you to start finding vulnerabilities in Rust programs in both Web 2 and Web 3, and you'll have all the knowledge required for you to join our other classes or explore more advanced Rust security concepts. So a bit about us. Gwenka is a security research firm. We specialize in Rust security, Web3 security and Web2 security. On Web3 security side, we focus on non-EVM chains and non-EVM ecosystems, and here are the ecosystems we support, such as Near, Polkadot, Kusama, substrate-based chains, Fuel, and soon we'll have even more ecosystems that we support. A bit about me. I'm Timur. I founded Guvenkaya because I saw that non-EVM ecosystems in terms of security a bit left behind. Everyone is focusing on EVM solidity, and it possesses a huge risk for non-EVM ecosystems. There are not many security researchers and lack of resources. So I want to change this. So I'm creating relevant Rust security, non-EVM security content, and as part of Gwenka, offering security services to projects in non-EVM ecosystems. So before actually starting working at Web3, I used to work at Invictus Security on Web2 side, where I was part of designing JSON Web Token security engine for their flagship product, which is Web Application Vulnerability Scanner used by many Fortune 500 companies. And at Halbon Security, I was leading Rust security teams and was part of auditing myself or leading a team on wide variety of big engagements. And also I created Near Rust Smart Contract Security course, which is totally free on YouTube, and contributed by creating Rust and substrate security sections to the SANS blockchain course. So here are the socials. Don't forget to follow us. I'm going to be sharing many relevant non-EVM or Rust security content there. So, and doing some different announcements. So I guess we can start with the table of contents. We're going to start with error handling, arithmetic issues, and then we have some additional topics that we want to cover. By no means it's full list that Rust security has to offer. There are more things, but those are foundations that you should have in order to explore more advanced concepts. So let's start with error handling. Rust has two types of errors, recoverable and unrecoverable ones. Recoverable errors are just regular errors that you can handle gracefully. If something goes wrong, you can display a message to a user or run some logic, like, I don't know, user entered a password which is less than 8 characters, you just show an error to a user. So it's like, you expect this error, you know how to handle it, you can gracefully handle this. Unrecoverable errors are errors that if something goes wrong, you don't know how to handle it, so your thread just panics. So, and panicking behavior in Rust is not the greatest thing in the world. Like, it might lead to a crash of program, so we should try to avoid it as much as possible. Obviously, there are some caveats, but in general, it's advised to handle errors more gracefully via recoverable errors and the result type. So let's start with recoverable errors. And before I continue, you can access all the materials under the link in the description, which is going to lead you to a GitHub. And also you can just check it out on our post on the social media. We're also going to link it there. So let's start with recoverable errors. So Rust has an amazing result type, which basically just enum with generics. T represents some value and E represents an error. So T is a generic type, and it basically just denotes a value returned in OK variant. So result is just enum with OK and error. And error, basically E represents an error that's returned inside of the error variant. So that's how you would usually handle errors in Rust. So you have, let's say, method open on a file. Here's an example, just trying to open a test.txt. And this file open returns a result type, which either returns a file object or some error. So we just do a match on on this method, and if everything was well, we just return a file object and assign it to a variable. If there was an error, we simply print an error and exit the process gracefully. And if everything went well, we just print the metadata of a file. So pretty straightforward. So let me go to code and show you how it looks if we run the program. So let me actually open it here. Recoverable errors. So here you go. So here we just simply have we're trying to open test.txt and then matching on a result type. So let me run it. So let me just do this. Recoverable errors manual. And here we go. File test.txt cannot be opened, and we get an error which coming from this method. So everything is pretty simple, and we handle the error gracefully. So now let's go to another way how we can handle this error. I mean, sometimes like doing like a match explicitly can be daunting. Like there are many places where you have to handle this. So there is like a shorthand, which is question mark, which basically does the same thing. So it means just propagate an error out. So if, let's say, try open results returns a result type, and the place where we call try open also returns a result type, we can just do question mark and we'll just return an error out from here. So it's just a nice shorthand. So if I go here, a recoverable errors question mark, exactly the same thing. Main returns result type, and file open also returns result type. So we can just do a question mark in here. So let's do question. If I could type, here we go. So yeah, and we just returned an error here and everything. And we handled the error gracefully. We didn't panic, we didn't crash, so all good. So let's continue with unrecoverable errors. And before we continue forward, we should mention that there are two ways, basically, how Rust can panic. There's like unwinding and aborting. Like with unwinding, when you panic, like thread just shutdowns relatively gracefully. Like it's not as good as we would have just handled error in recoverable errors, but still, like it reclaims resources. It does not kill the whole process. Destructors are called, and many Rust frameworks, let's say in the web, if I give you an example, Actix, Axum, they can handle those unwinding panic. So I catch unwind or setting hook and taking hook, and it can return like on those panics instead of crashing. It can return 500 internal server error. It's super useful because like not every time you have an ability to determine whether something will panic or not. Like you like missed something, or you try to access an array out of bounds or something like that. So an Actix or Axum, instead of just panicking or crashing a program, they will catch an unwind and return 500 internal server error to a user. But in case of abort, the whole application process is killed. Like it just crashes everything, crashes the program, and it usually occurs in like a catastrophic events when Stack Overflow or out of memory issues occur, or if we specify panic abort in cargo.toml. So we can just specify either panic unwind or panic abort. And like if you specify panic abort, it decreases the binary size. And if you, as a security researcher, see that certain project has a panic abort, especially if you're auditing, let's say, a Web 2 application, it's either developers handled everything and they're super confident in their code, and so they decide to add panic abort to just decrease the binary size, or otherwise, those are developers just Googled like optimization tips for Rust and just copy and pasted the code. In that scenario, I mean, you'll probably find many security vulnerabilities in that code. So here is just a simple example. We have just main, which panics, and if we don't have a panic abort, it just panics usually, just thread panics. But if you have a panic abort, like the whole application process crashes. So let me show you an example. So if I open panic, yeah, here we go. Actually, give me a sec. Yeah. So let me run a panic. Here we go. Just thread main panicked. Yeah, just a regular panic, just thread panicked. But if we go now to cargo.toml, let's say here, enable panic abort and compile in the release mode because we just changed the release mode. So Rust has two modes, debug and release mode. And here, as you can see, we just abort. Instead of just closing the thread, it just closes the whole application process. So let's continue. And we can use catch and wind to catch panic, and as I explained before, display some certain error message to a user. Like here we have, let's say, a something, and we just catch and wind, and we panic inside. If we didn't have catch and wind, we wouldn't be able to reach this part of the program. We would have crashed here. But here we can actually assert that it's an error and then display an error message to a user. As you can see, we panicked here, but still we reached this part where we displayed an error to a user. So, and exactly the same thing. I mean, not exactly the same thing, but we can set a hook which is gonna be globally applied till we take it out. So here we set a hook, which means like, on the panic, it's gonna basically just print custom panic hook. And here on catch and wind, let's say we have some panic. And instead of panicking, we're just gonna print a message. And here we take it out, and here we panic as usual. So let me show you those examples. It should be catch and wind. Yeah, exactly. So I mean, division by 0, it's gonna panic. I mean, if you divide by 0, what did you expect? So here we're dividing by 0, we're dividing 100 by 0, so we're gonna panic in here, and we're using catch and wind to catch it. And instead of, basically, if we didn't have this, we would have panicked, but now we're just gonna print an error message. So let me actually run it, catch on wind. If I could type, did you mean catch and wind? Yes, I meant that. Here we go. So attempt to divide by 0, coming from here, and we just printed panic occurred. And again, I mean, let me just do something like this. So if I do this, let me do that, comment this out, comment this out, add some, like, I don't know, print the print statement with something. And now if we rerun it, we won't be able to reach this part, as I explained before. Like, as you can see, we just panicked on attempt to divide by 0 in here. Okay, awesome. So let's move to setting up a hook. Here, exactly the same thing. So we're gonna run it, set hook. This is a panic. So basically we just first we set up a global panic hook, which is going to display some error message. So as you can see from here, we're trying to divide by 0, but instead of panicking, we just print this is, we print some error from here. And then at the end, we take a hook out, and then from now on, it's going to be just the regular panics. Okay. So let's move on to the next part. It's unwrap and expect. So you saw how you can gracefully handle the result types and option types. I mean, just give you TLDR on option types. It's also an enum, which basically it basically denotes if there is a value or there is no value. I mean, especially useful, let's say you're building CLI and you expect the user to enter something, but user can just simply not enter anything and click enter. And in that scenario, it's better to wrap your type with options, so that you can handle it gracefully later on to assert whether the value passed was none. If it was none, do something. It was some, do something. So I mean, same concept. You can use match keyword to just match on some or none. Unwrap and expect, it's like just easier shorthand with some caveats. So it means that either if there is a value, if we are dealing with option type, return a value. If there is if everything was cool, everything, there wasn't an error and there is a value, just return a value. That's all. That's what unwrap does and expect as well. But if there was an error or value was none, panic. So when you encounter this, you have to be 100% sure that this part won't panic. I mean, it makes your code easier to read, but I mean, at the same time, it's gonna throw you a panic if the value was none or there was an error. So when you auditing or reviewing a code base, it's better to just maybe in the beginning just quickly run through all the unwraps and expects and verify that those indeed cannot panic. So I mean, just a quick tip. So I mean, difference between unwrap and expect is just expect. With expect, you can pass a custom error message. Apart from this, they are the same. So let me go to unwrap and expect and just run it. It was unwrap expect. Unwrap expect. Okay, so as you can see, we just panicked with some message, error opening file, and actual error which occurred. And let me move myself here. Okay, so let's continue. I mean, especially if you see that the cargo.tom has panic abort, those will just simply crash a program. So yeah, just make sure that those won't panic. And panicking macros, you have to know them. So panic, I mean, yeah, it means panic. So unreachable, in some code bases, you can see unreachable macro used to denote that something is unreachable, but sometimes it's actually reachable. So you can use a different technique like fuzzing, and sometimes it can actually reach that part which developers thought is unreachable. In that case, it might actually crash a program or just throw a panic. I mean, to do self-explanatory, assert, just assertions, which actually panic, debug, assert, same concept, and unimplemented as well. So here is an example. We just get a value from a user, and then we just, depending on the value, reach different parts, different macros from here. Pretty straightforward. Nothing too complex. Let me actually go to panicking macros. Actually, let me clear this part. So I already written some conditions. If there's no number or number is not integer, we're going to be panicking on unwrap. It's because we are trying to parse a value as basically as I32. But the thing is that, I mean, if the value is not if value is not a number, we won't be able to parse it if you enter just something else. So let me actually do this. Panicking macros. Let's start with this one. Let's say we enter A. I mean, as expected. So we panicked on unwrap. Let's try again. Let's enter odd number. So as you can see, we have a condition here. Only even numbers are accepted. So we're panicking here. Let's enter an odd number, like 3. Only even numbers are accepted, and we panicked. Okay, so if the number is larger than 10,000, we're going to just panic on unimplemented. So I don't know, let's enter something like, I don't know, 10,000, like something big. I don't know, do something like this. Yeah, here we go. Not implemented. Next one, we just assert if the number equals to secret number. In this case, it's 28. Let's enter, I don't know, 30. Here we go. You picked a wrong number, so we panicked on assert. Right, so let's continue. Again, like when you're auditing code base, make sure that those, like if you see unreachable, it's actually unreachable. So let's start with the big topic, arithmetic issues. There are plenty of them in Rust and Rust code bases. So integer overflow, underflow, it's pretty easy. Like if you do certain operation and the result is larger or smaller than the maximum or minimum value that certain type can hold, leads to an overflow or underflow. Like in Rust, there is like silent overflow, underflow, or panicking ones. Silencer just wraps around the type, which in my opinion, like, but in general, like it's worse because it does not panic, but it just causes a big logical errors inside of your program. And it's especially dangerous when you compile in release mode, because in release mode, when you compile just by default, integer overflows are silenced and not caught during runtime. So you will have some severe logical errors. So here's just an example. So let me actually just run it. Integer overflow. What was it? What was it? Underflow, I guess. I called it underflow. Yeah, here we go. Okay, so simple, like we just subtract b from a, and here we just read a value from a user, and then we get the value and subtract 6. So now let's do underflow. Let's say we enter 5. What's going to happen? We're going to panic because we compiled in debug mode. So there are some runtime checks. However, if we go to cargo.toml, as you can see, there is no like overflow checks yet. And we compile in release mode now. And we enter 5 again. We get 255. The reason behind this is that the type is U8 and the maximum value we can hold is 255. So it actually wraps back, since there is no like -1, wraps back and goes to the maximum value, which is 255. And imagine if it was a real code, I mean, it would have caused many severe logical errors, especially if it was like decentralized finance or some other application which deals with numbers and finances. So let's actually add overflow checks true and repeat the process. Probably it's gonna recompile. No, actually no. And as you can see, we just, yeah, I mean, we aborted. I mean, usually it should panic, but we have panic abort. But yeah, you get the concept. We just basically, instead of returning, actually, let me just remove it. Instead of returning incorrect value, we just panic. So let me actually wait a bit. 1 second. Yeah, I mean, sometimes compilations can take a while, but luckily our application is pretty small. Yeah, here we go. So if we enter 5, yeah, I mean, thread main panicked. So all good. Attempt to subtract with underflow or with overflow. All right, so let's continue. So prevention, how we can actually prevent this? So there are 2 ways. Like if you want to use custom methods, there is checked maths, and checked maths, instead of overflowing, underflowing, it actually returns an option type back. If the operation was successful, no overflow or underflow, it just returns a sum value, and then you can gracefully match on it. If there was an error, sorry, not error, but overflow or underflow, it returns none. So what you'll do, you'll just gracefully match and see if there was an overflow, just do something, return a value to a user, run some logic, or if everything was well and you received some value, just continue with your operation, and you can get the list of all of them here. And saturating maths is even simpler than that. Like it's just gonna, if there was an overflow, it's just gonna keep a value at its maximum. So in case of U8, it's gonna keep it at 255 and minimum at 0, so it cannot overflow. But you have to keep in mind when to use which. So like you have to know what's, like, for instance, saturating is doing, and whether you're okay with having maximum value on overflow. So in that scenario, you should be aware of them and use appropriately. So here is just an example. If I go here, prevention, overflow prevention. Let me just run it first. Here we go. So we have just underflow checked. Basically, we're using checked maths to do subtraction, and overflow saturating, we use saturating addition. So here we have just basically underflow checked. We get an option value back. So we subtract 5 minus 6 and we get an option. And then we can just match on it to determine whether there was an overflow or not. So here we have overflow saturating, and regardless what's going to happen, it's going to return 255, which is the maximum value of U8. So as you can see, like we add 10 to 250, which is 260, but the maximum value that U8 can hold is 255, so we're going to get 255 in here. And here we check whether the value is none. If it's none, we're just going to print and exit the process gracefully without any issues, without panicking or without anything. And here, if everything was well, we unwrap. So that's the case about unwrapping that I mentioned before. We already checked that it's none, so it's safe to unwrap here. So there's no problem. And also in general, like you can use unwraps, expects when you just scaffolding your program, just or in tests, like in tests is okay. Or if you're just, as I said, like a scaffolding your program, writing a POC, and it's not actual production software that you're planning to deploy. So let's continue with next topic, which is casting overflow. Casting overflow is also pretty simple. It's when you try to cast a bigger type to a smaller type, and the value that bigger type holds is larger than the maximum value that the smaller type can hold. So in this example, as you can see, we have U16, which holds 300, and we're trying to cast it to U8. And since 300 is larger than maximum value of U8, which is 255, we're going to get a casting overflow. And there are like several ways how you can cast in Rust. We can use ask keyword, but in case of using ask keyword, it won't panic, but it's gonna wrap around the type. So you should always keep in mind that and double check where you use ask keyword, because it might lead to severe logical errors. So it's a silent casting overflow. And there is like panicking casting overflow. Like in this example, there is crate called primitive types used in Substrate. So there are some custom types, and they have custom methods, let's say as U128. And in this scenario, it won't actually panic, but it won't actually wrap around the type, but it will panic on overflow, which is a lot better. So let me show you an example. And it was here, I guess. 1 second, casting. Yes, I mean silent. Let's start with silent casting. Again, everything is available on GitHub. If I could type. Here we go. We got 44 back when we try to cast U16 to U8. And now let's go to, it's called, I guess, panicking casting. Yeah, here we go. Panicking casting. Okay, and we just panicked on overflow, as you can see from here, which is a lot better. Division by 0, I mean, if you divide by 0, you're gonna panic. I mean, it's just simple as that. Make sure you check denominator. That's all. I mean, I won't be showing an example because it's pretty straightforward. Rounding direction. We have to keep in mind where you're rounding your values. So there was like, there's several rounding methods in Rust. There's round, ceil, and floor. Round just rounds to either just up or down to the nearest integer. So if we get 1.5, it's going to round to 2. If we get 1.4, it's going to round to 1. Ceil always rounds up. Floor always rounds down. So we have to be sure that we round to the correct direction, so we won't have any logical or calculation mistakes. There was a bug in Solana ecosystem. I won't be going into details. You can read it here, but just TLDR, they were not using the correct direction. So you could come up with certain transaction which gonna yield a certain value, let's say, making that up, let's say 1.5, which is gonna actually return 2, and just out of thin air, it's gonna return you additional money. So if you repeat it long enough, you can actually drain some large sum. So let me actually show it to you. Round. So it's just a made up example here. And let's run it. Okay, so here 1.5, we're using get rewards, and then we're using round. 1.5 rounded to 2, seal also to 2, and floor rounds to 1. So pretty straightforward. So when you're auditing or reviewing a code base and you see those, just double check that's the intended direction that the developer wants to round. I mean, if you just also, just to be clear, also if you just simply divide, it's gonna floor. So we're gonna explain it here, but also just keep that in mind. So order of operations matter. So when you divide before multiplying, and always depending on the type used, it can lead to precision loss or even like totally incorrect value returned. So when we operated with non-floating point numbers, upon division, as I explained before, the value is floored. So let's say we divide before multiplying, so we divide 30 by 13. It actually yields something like 2.3, but since the value is floored or truncated, it's going to give you 2 back. And then when you like multiply by those values, you're going to return to 2,600. However, when you first multiply and then divide, we get the 3,000 back. Like, it's a big difference. It's, imagine like we got like totally incorrect value in here. So, but when we operate with floating point numbers, we might encounter some floating point errors, and depending on your error tolerance, it might be devastating, it might be okay, but still, like, it's better to first multiply than divide. So here, if we divide first, we're going to get 2,999 dot and something else. But if we multiply first, we get 3,000 back. Also, there is another way. We first when we operate with floating points and then we convert to non-floating point. Here we have this, but when we convert it to non-floating point, we remove that part, it gets truncated, so we just get 2,999. However, when we first multiply, then divide, we get 3,000, which is correct. So here is just some example that we can run now. It was division, divide before multiply. Yeah, here we go. So let me just run it. Divide before multiply. Here you go. So as you can see here, the one which is correct, like this one, gets rewards right. So we first multiply, then divide. So we get 3,000. Then the wrong one, we first divide, then multiply. So we get 2,600. Then we do the same thing with the floating points. And then at the end, we start with floating point and return non-floating points. So as you can see, values here. So those are incorrect. So let's continue. Default values. Every type in Rust, like majority of types in Rust have default values. And we have to be aware of them. Sometimes developers, like if they want to silence a compiler or don't want to match on a type, if there is like an option or error, they might just throw like unwrap or default. If we can unwrap it, no problem, it return me actual value. If we cannot unwrap it, just return me default value. Sometimes it's okay, but sometimes if you are not aware what the default value is, it might introduce some logical errors. So especially if you see a custom made type and you use unwrap or default, it's super risky because you have to then go to actual type and check what the default implementation is. Just don't blindly trust it. For instance, but there are some well-known types and what's they return. Like, for instance, unsigned integers by default return 0. Or let's say an option type's default value is none. So you should be aware of those. So here, like, there was an actual hack in a Kali network I won't be also going into details, and also there was an actual like a hack breakdown. I mean, I might actually do that so that I can release it, but just from their patch, it's clearly that there are two things that we already mentioned before. They use incorrect way of preventing overflows, so they use saturating instead of checked, and apparently saturating was not the right thing, so it wasn't giving them the correct value that they wanted, so they were not okay with the maximum value. And also they were using unwrap or default, so they were returning a default value of a certain type, which also turned out not to be the great choice for them, so which introduced a bug in their code. So here is just a large example which explores different unwrap or default values. So let me actually run through it. Default values. Here we go. So let me do here, clear. I'll remove that. Okay, so we just have some A, B, C, D, E, and so on. And we have some values assigned to them, and we just bring them out with unwrap or default. Okay, so let me just run it. Default values. Okay, here we go. So 1 second. So let's start with the first one. So here, if we unwrap our default sum 2, since there is a value, it's just going to unwrap, so it's going to return you 2. And here, since it's none and the type is U128, default value of U128 is 0. So on unwrap or default, B is going to be 0. Here is a bit interesting one, those two. So here we have nested option type. So you have sum of none. What do you think is going to return? It's going to actually return none. And here it's also going to return none. As you can see, C and D. However, they return none for different reasons. This one returns none because in case of sum, there is actually some value, even though the value is none. So on unwrap or default, it's actually unwrap part which returns none. But here is the default part which returns none. Because if we just go like C and D, right? Like if we change unwrap or default to just unwrap. Let's change it to just unwrap. Let's first change C to unwrap. It's still going to return none. Because there is some value, like there is some value inside of sum, and we just unwrapped it, even though it's not. However, if I change this value from unwrap to default to unwrap, it's gonna panic. As you can see from here, panicked on option on unwrap, because we actually returning a non-value here of the outer option type. And default value of an option type is none. That's why when you do unwrap or default on an option type, it returns none. So let me just go here. Let me just rerun it so we can see everything. Okay, so let's go to E. Result type, same concept. Since there is a value, it's just gonna unwrap 2. F, since there is an error and the type is U128, it's gonna return default, which is 0. G is a nested result, an option within result type. So we have awk of sum 2. So it's going to return sum 2. Here we have to unwrap twice. So first unwrapping the outer part, and then we have to unwrap the inner part. But since we just only unwrap the outer part, we just get sum 2 back, as you can see from here. And here we have awk of none. Again, since there is none value inside, we just return none. Again, if we try to unwrap it again, then it would have caused a panic. We just used plain unwrap. So let's continue with a custom type that I was talking about. So we have a custom user type. As you can see in here, I implemented a default trait for a user. So, and I put by default name Jake and age 34. So here we have option of a user. So, and we have some user which is Jane22, and we just unwrap our default since there is a value which is returned a Jane22. And if we assign non-value to a user and do unwrap or default, it's going to return a default implementation, which is Jake 34. Again, same concept with the result type. Since there is a value, it's going to be Jane22. If there is an error, it's going to be Jake 2034. So yeah, that's pretty much it. Index out of bounds. Pretty straightforward also. If you try to access an index out of bounds, you're gonna get a panic. So instead of this, you should use .get, which is gonna return an option tab, which you can gracefully match against. And if there is none, you can handle it more gracefully. I won't be showing an example for this one because it's pretty straightforward. Stack Overflow. So Stack Overflow, like this one, is gonna just crash your program, close the whole application process. So you should be pretty careful with this one. I mean, just to give you a brief, like Stack Overflow, it happens when the program consumed more memory than the call stack has available, and like it's usually occurs in recursive implementations of functions because you constantly add something on a stack. And also it can be not only just, let's say, not just factorial calculation, which is recursive itself. It can also happen if, let's say, there is a function which calls another function, which let's say function A calls function B, and function B calls function A back, and it just repeats itself. So in that case, it also can happen. So here we have the just a factorial calculation, and we have factorial calculation with some value. As you can see, it's recursive. So eventually it's gonna lead to a stack overflow. So let me run it. Stack overflow, here we go. As you can see, this value does not cause stack overflow since we have apparently enough memory. So let's actually increase it and repeat the process. Now, as you can see, we got an abort because of the stack overflow. So in this scenario, if you imagine it was a real program, this program would have crashed. So when you're auditing a program, you should be careful. If you see recursion, double check that there is no stack overflow. You can just easily try inputting super large value in there, or assert that no one can input a super large value there, whether it's actually controlled. So out of memory, I mean, simple, like if there's not enough memory to allocate for a program, it's gonna be out of memory issue and it's gonna abort. Like if the buffer is not checked, if we have unbound data types, or we just simply allocate a huge chunk of memory, so it's just gonna lead to out of memory issue. So let me repeat this one. Actually, let me go to out of memory, OOM. Here we go. It's super simple. We start with 124 and we're constantly allocating some memory, and on each iteration we just double the size. As you can see, we first started with 1024, and then we're doubling. Eventually we reached the part where we cannot allocate more and we aborted. So this one would have crashed a program. Okay, so let's continue with crates with known vulnerabilities. So there is Rust Advisory database where if you discover some issue with the crate, you can, it will, if you report it and it gets fixed, it will eventually end up in the Rust Advisory database where if you use cargo audit, it will traverse your dependency tree and display some vulnerabilities in your crates. I mean, simple as that. Obviously, not everything is actually exploitable in your own program. It maybe can be super deep in the dependency tree, and you cannot just simply fix it or upgrade it without breaking your outer dependencies. So you have to double check and see if you can upgrade it. If you cannot, just make sure that it's not exploitable in your scenario. So here are some handy Rust tools. We won't be talking about them in this class. Some of them are more advanced, and some of them are mostly for unsafe Rust. So in advanced class, we're going to cover some unsafe Rust vulnerabilities, but in this one, we focus solely on the safe Rust to cover the foundation. So Cargo already talked about this. It's cover vulnerabilities in crates. Cargo Clippy, it's amazing linter. It's going to catch common mistakes or bad practices in your code. I learned a ton of Rust and good practices from just simply using Cargo Clippy, and you'll be surprised that not everyone is using Cargo Clippy. So yeah, Miri, so it's just Rust mirror interpreter to discover basically a wide variety of memory issues. It's more useful if you deal with unsafe Rust. Cargo Geiger, it just discovers unsafe Rust within your code, within crates. So it's sometimes useful to just run through it. I mean, if you, let's say, I can imagine the use case of it is that if you're using, if you want to discover, let's say, unsafe code inside of different crates so that you can go in there and try to find bugs in them. So that can be useful. So Cargo Tarpaulin, just to measure test coverage. Rust Analyzer is just like, if you're working with Rust, most probably you already have it, but just in case someone is new, Rust Analyzer, just install it. It's the amazing LSP and ID code extension, like code completion, code checking, and everything. Cargo Expand expands Rust macros. Super useful. If the code that you're reviewing has some custom-made macros, it's not always that easy to understand what's is being written, because macro, like regular Rust and macro Rust, is super different. Like it's not the same thing. You're not exactly writing the same Rust code there. So it's super hard to read sometimes. So what you could do, there is like, imagine there is a proc macro. What you do, you run cargo expand and you see expanded desugared version of this, what's actually being pasted inside of your code. And then you can deduce what it's actually doing, and you might be able to find some mistakes there. So that's the power of cargo expand. Cargo fuzz, long fuzz, fuzzers, and cargo algrant is just to discover memory leaks. So if we, I mean, that's all, like when it comes to the topics that I wanted to cover today. However, like we also have a small CTF so that you can test your knowledge. So here's the small CTF. We have just several things in here. You just can do cargo run and just run the code, and then try to exploit issues in every single path. That's pretty much it. And if you exploit everything, just DM me and I'll congratulate you, and I'll also shortlist you to, so that you can get a notification when we release more advanced courses. So yeah, that's pretty much it. Again, let me go back to our socials. Again, here are our socials. Please follow us. I'll be releasing more content. We're going to be making more announcements. And yeah, thank you for taking this class, and let me know if you have any feedback or anything that you think would be valuable for us to cover in more advanced Rust. Thank you.